computer. All right, so again, we're recording. Just please feel free to ask your questions. Don't worry about that whatsoever. Just let's not use any names in these videos. Okay. All right. Let me switch cameras here. Perfect. Let's get this out just a bit. And that's upside down, isn't it? There we go. I apologize. We'll get going here pretty quick. So last time we talked about line styles. And this is, let me go into my video settings here. I need to mirror my screen, so let me. Where is it? Video settings, beautiful. There we go. Okay. Don't mirror the video because apparently the camera already mirrors, so it's getting mirrored then mirrored. Okay. Paused. It is still recording. All right, that's fun. All right. Thanks for bearing with me. I apologize. Let's see if we can get productive. So last time we talked about line styles. Right? We talked about line styles. Let's focus in there. Good. Okay, this is going to be graphics. This will be L2 basically. Let's go page 1. Perfect. We said there were thick and thin line types. Nominally 0.6 millimeters and 0.3 millimeters. We're not going to measure those. Just the things that are supposed to be thick line types make them thicker. Things that are supposed to be thin line types make them thinner. I'm not going to measure to make sure you're conforming to the 0.6 millimeters, 0.3 millimeters. That's just silly. But we said that your visible line types those are thick lines and they are solid. And these represent things that can be seen in the current view. And we're going to talk about multi-views today. We talked about several line types. Let's talk about the main ones. 3 that are kind of bread and butter, especially the first 2 here, are real bread and butter. The hidden line type, those are thin and they are dashed. And it's just a short dash that repeats. And again, for me, if I'm just using a pen or pencil, the easiest way to ensure thin versus thick lines is to just simply do multiple passes with thick lines, single pass as best possible. A single pass for the lines that are supposed to be thin. And with pen or pencil, that normally gets you pretty close. We talked in the video and also in the text I've made available to you, there's information about the size of these dashes. I'm not going to measure your dashes when you're drawing them by hand, right? Just, it's a short dash repeating, right? Thin line, short dash repeating. And from time to time, we will see the center line. That is also a thin dashed line, but the pattern and size of the dashes is different than the hidden. So again, thin line, so pen or pencil, I do my best to just make a single pass. The center line is a long dash, short dash, long dash. Okay. All right, thank you for your patience with me here. Let's talk about drawing in 2 versus 3 dimensions. Okay. And that's going to be our focus today. I'm kind of zoom in a bit here. Try to get a little more out of our real estate here. All right. Again, I'm getting better with this document cam, but I'm not used to using this particular style, so that's okay. All right. So, you better than that, right? There we go. All right. So if we want to draw things that are two-dimensional or three-dimensional, so here's the thing. We have what we call let's look at types of 2D drawings. And the main type that we're really going to focus on here is what we call an orthographic projection. An orthographic projection. So an orthographic projection is a two-dimensional view that is taken from a point of view that is perpendicular to the plane being drawn. Right, that was an orthographic projection. Now, what the heck does that mean? Well, we saw this, a good example. We weren't using this terminology yet, but we saw this last time. We said, well, you've got this, if I just draw a 3D view, we're going to talk about where to find this in a little bit here, of, let's say I've got like a cup here. And we saw this last time. We said, well, we've got a cylinder with the internal cylinder removed, a cup, if you will. The orthographic, I'm just going to call it the orthographic projection of that would be what we drew last time, the two-dimensional view of that, where I'm looking right straight at it. And so if I'm looking right straight at it, I'm not going to see curvature. I'm going to make these thick, visible lines here. So I'm going to go over them a couple times. If you've got different thicknesses of lead, you can make your lines thicker that way. There's a variety of ways you can make thicker lines, but you want to make sure those visible lines are in fact thicker than the hidden lines. And then we can communicate to the viewer, hey, there's something going on in here you can't see from this view. And if you like, you can communicate there's some symmetry right down that axis. All right, so this would be an orthographic projection. It is a two-dimensional view taken from a point of view perpendicular to the plane being drawn. In this case, we're drawing basically the front plane, where we'd be looking right straight at this thing, perpendicular to it. We get down eye level with this thing, where I'm looking right straight perpendicular to the front plane, if you will. Or we could also look at the right plane, and we'd probably get the same projection in this case. So that's, just very quickly, that's an orthographic projection. Now, as we mentioned, just from this view, if I don't have this, and just from this view, I know I've got something. I mean, what is this? Well, that's the challenge, is if I'm trying to draw a three-dimensional object with a two-dimensional projection, I've got to sacrifice something. All right, I'm going to make that note. A two-dimension view of a 3D object requires sacrifice. In the case of a projection, so for orthographic projection, The sacrifice is this. We need more views. Oh, sorry, I'm off the screen. For an orthographic projection, the sacrifice is this. We need more views. Again, without this, I can't tell you what this is. This is just one view. It's accurate. And I mean, I could draw this accurately. I could draw this to scale. All my angles here are correct. Everything about this drawing is correct. It's just not everything I need to know because it doesn't represent the whole three-dimensional object. It doesn't tell me everything I need to know. But this one view tells me everything I need to know about the front projection or the right projection. That's the sacrifice. Is with an orthographic projection, I need more views. Yeah, come on forward if you guys need more room. I need to go full screen. I apologize. Go back full screen. There we go. See you guys on the projector. You can see this. All right. So we need more views. That is our challenge there. Now, if we typically we will use front, top, and right views to fully define an object. So those are the views we will normally use, is front, top, and right. This is page 2. Now the question becomes, what is the front? Got just a standard projector remote there. What's the front? Is there a front? Is it this? Is that the front? Is that the front? Yeah. It's relative. It's all relative. That's what you have to understand. It's all relative. Now, there's some bad things we could call the front. This is probably the worst projection we could call the front. Correct? Makes sense? It's relative to whatever we want to be the front. But we probably want to actually think about what should we call the front? Is there something that makes sense to be the front?
Maybe like the face with the most details or most features.
Exactly. Exactly. And a lot of texts will say exactly that right there, something to that effect of, you know, that what is the front? Well, the correct answer here is ultimately it is up to the drafter. But again, there's some very bad answers as to what the front should be. The best answers to the front would be the projection with the most detail. Is ideal. Okay? Sometimes it depends on the function of the part. All right, so if we were to draw, an example a lot of text will give is if we were to draw a car, if we were to draw views of a car, orthographic projections of a car, well, would looking at the hood be the front, or would maybe from one of the, either the passenger or the driver's side make more sense to be the front, because that's, you can see more detail, more of the shape, more of the contours. Would I say you were wrong if you said looking right at the hood is the front? No, I probably wouldn't. That's kind of what a lot of people would think of the front. But is that where the most detail is? A good rule of thumb is which projection would allow me to have the fewest hidden lines is a nice rule of thumb. If there's a projection that I could call the front, and then showing the front, top, and right, I end up with the fewest hidden lines. Well, that's a nice candidate to be my front projection. These are not laws. These are not rules even. These are just really good things to think about and suggestions. Ultimately, it's up to the drafter. You being, whoever's creating the drawings being the drafter. If that's you, it's up to you as what the front is. But there's definitely, as we said, there's some things that it would be very bad to pick as the front. Okay, so that brings us then to what we call the, move this down just a bit. That brings us to what we call, the multi-view drawing. So the multi-view drawing is a collection of two-dimensional drawings that work together to fully define an object. They may include a 3D, what we call a pictorial, what we call a three-dimensional pictorial. They may include a three-dimensional pictorial as well. Not required. The two-dimensional drawings to fully define the part, that's what's required. I have to have the two-dimensional drawings needed to fully explain and define the part. Maybe it makes sense to include a three-dimensional view as well. Okay. Again, you as the drafter must choose the most descriptive views. You as the drafter must choose the most descriptive views. But again, it's often front, top, and right. And then it comes down to, okay, which is the front? Pick the front such that when you also put the top and the right projections with it, you get the most description out of those three views. If at all possible, you want to define the entire part just off those three views. Some simple parts we can define just off of two views. We'll see a little bit of that. Okay. All right. What else then? There are 6 common orthographic, I'm just going to say orth projections, orthproj. There are 6 common orthographic projections we can use. And those be left, right. You can use front or back or the rear, front, back or rear, it's the same thing. You can use the top, sometimes called the bird's eye view, and you can use the bottom, sometimes called the worm's eye view. What do those look like? Well, if we refer back to our three-dimensional cup, the front, we often say, is basically looking up this way. The right, we'll say, is looking this way. And the top is from the bird's eye view. It's looking straight down. The others are their opposites. So the rear is looking back this way. The left is looking the opposite of the right. And the bottom, or the worm's eye view, is looking from the ground view. Now, if we were to draw these, as we have before a few times, if I draw the front view, it will look like this. I won't see the whole thing. I can communicate to the viewer, hey, there's something going on in here you cannot see. Give them symmetry if you like. This would be the front, looking this way. You would also see the same thing if you got down eye level with this thing and look at it from this side. You'd see the same thing. So this is also, we would see the same thing in the right view. Coming back from the left. Again, I would see the same thing from the left view and coming back this way. If I got behind it, got down eye level with it and looked right at it, I would also see the same thing from the rear. This is a special case. This doesn't happen very often where this many views are the exact same. It's very rare. This is a very simple part. So this is a case where that many views will actually look the same. If I look right straight down on this thing though, I can actually tell, because I can't tell if there's circular features from this view alone. I don't know that. But if I look right straight down on it, I will see the outer circle, the outer cylinder, and I'll see the inner cylinder removed. I'm going to make those good and solid. And if these are big circles, go in and set your center point, draw multiple points at different radii, connect the dots. Okay. Get a little more detailed. I'm just kind of quickly drawing for demonstration purposes here, rough circle. Doesn't have to be pretty, but I went back and made those obviously visible lines because I'm going to put now thin lines designating symmetry. So a common thing you can do there when you're dealing with a circle, if you'll put the short dash of your center lines intersecting at the center of that circle, that's an easy way to define where the location of that center of that circle. See what I've done here is these are, I've drawn, and I can extend them out. I've drawn center lines here. All right, this is a center line, this is a center line. And I've drawn center lines where the short dash intersects at the center. And that's what we'll see from the top. You won't see the center lines, those are construction lines, we don't see those, but they're there for our benefit. If I drew the bottom, if I look at this thing, if I pick this up and look at the bottom of this thing, well, I'll see the outline, circular outline. But from the bottom view, I can't see, if it's a cup designed to hold liquid, I can't see the inner circle. So I would have to communicate that as a hidden feature to the viewer. This being the bottom. And again, you could put your center lines in there. When you're defining a circle with center lines, put the short dash intersecting roughly at the center of the circle. Okay. Questions so far?
In SolidWorks, can you name the axes?
You can. Normally, they're already named as X, Y, and Z, and then you just build off of that. And so you get to choose what is your X, Y, and Z directions as you build the object. Yeah, the question was about SolidWorks. Do we get to name the axes in SolidWorks? Kind of. SolidWorks already has axes set up, and we just build our part around them. SolidWorks is very forgiving. I'm betting you probably could go in and name them whatever you like, but it'll start out as X, Y, and Z. Other questions so far? Okay. So as we mentioned a little bit ago, we're working our way up to this idea of multi-view drawings. It's a collection of these orthographic projections that work together to fully define an object. They're not actually This is a kind of a multi-view drawing, but it's not a very good one yet. Let's work our way up to it. Okay. Now, as I mentioned, we talked about multi-view drawings. They may include a three-dimensional pictorial. Let's talk about a little bit about three-dimensional pictorials, if we may. So let's talk about page 4, I believe. Page 5, actually. So let's talk about then 3D pictorials. There are a variety, we'll say that there's a variety of ways to represent 3D images on two-dimensional media, right? So, I mean, I've drawn earlier just kind of roughly a three-dimensional image, but this is not three-dimensional. This is a two-dimensional image. It's on a two-dimensional paper, two-dimensional media, and it's being projected on a two-dimensional screen, right? And if you're watching the YouTube video, it's on a two-dimensional device. This is not three-dimensional. This is not three-dimensional. But we can draw it in such a way that it has a three-dimensional appearance. And that's the idea of a three-dimensional pictorial. It's a two-dimensional image. It's a two-dimensional projection that looks three-dimensional in nature. You can achieve that. Now, they will all require a sacrifice, as we mentioned earlier. It requires a sacrifice. In the case of a three-dimensional projection, it requires a sacrifice of, at the very least, angles. Right? The angles are not going to be accurate because I can't draw something, you know, in 2 dimensions. I mean, yes, I can draw something in 2 dimensions there that's 90 degrees, but what about the one coming at the page there? Drawing that in 90 degrees perpendicular to both of these and holding these still 90 degrees, you can't do that. It's 2-dimensional paper. You run out of angles. So it requires at least a sacrifice of angles and possibly lengths. And at least one direction you'll sacrifice the lengths. It will not be accurate. It'll be some scaled version, adjusted version. There are a variety of methods. Okay. Here, we will talk about what we call parallel projections. All right, so there are things called perspective projections where maybe if you've had an art class, they've taught you to draw in perspective where the lines are not all parallel. They kind of reach a vanishing point. There's some nice examples of that if you want to just go look up perspective drawing. And we're not going to talk too much about those. Again, our goal is not for you to be artists. Just want you to be able to do some hand drawings. We're going to focus on what we call parallel projections. And there's 3 main categories that we're going to focus on, being the dimetric, being the dimetric, the trimetric, and the isometric. Okay. So here's what you have. You have 3 axes. You have 3 axes. Right? A lot of times I'm going to refer to them as X, Y, and Z. And that's how I will often draw them, is X, Y, and Z. And so this is kind of an example of roughly a dimetric. We'll talk about that in a second. So X, Y, and Z is good. This is also kind of the front rear. The X-axis is basically the front rear. Depth, if you will. We'll call it the depth. We can call them a variety of things. Just keep them pretty standard and short. I like to call this the X direction. This is the front to rear direction. Could be the depth. The Y direction being the left to right, the width. Right? The Y direction is the left to right. The Z direction is the vertical, up and down, the height. Right? These are all fine, but we'll call them Z. And these are the orientations I'll use. SolidWorks, I think, likes to put Y in the vertical, and it'll put X, Z in there in the other planes, and that's fine. This is how I was learned. That's probably how they're going to teach you in your calculus classes. I know we use this in statics a lot of times, so it's not uncommon we'll draw in this orientation or some version thereof. Right? Now again, so those are three axes, often called the axonometric axes or the parallel axes, if you will. We mentioned there's dimetric, trimetric, and isometric. They're all describing how these three axes interact. Right? So if it's trimetric, that is where all three axes are at different angles. Trimetric is where all three axes are at different angles. Okay. What does that mean? Well, there are infinite possibilities. And infinite possibilities. Here's one example. I apologize. I'm thinking about 5 things and I'm trying to write, and sometimes it's working, sometimes it's not. All right. So a lot of times I like to, if at all possible, leave one axis either up, down, or left, right. Always, if at all possible. That means at least one direction will be easy to draw. That's my word of advice, my sage wisdom, if you will. Now, sometimes it might make sense to draw the y-axis off this way. Right, so if we call this Z, we call this Y. And sometimes maybe it makes sense to draw the x-axis off this way. Okay, that's pretty challenged. I wouldn't draw anything this way, but I've seen some crazier setups. Okay, and notice the angle between these axes as I've drawn them here is roughly 180 degrees. This is less than 90 and this is greater than 90. And any configuration where the angle between all three of these axes is different, that is a trimetric configuration. Okay. This is definitely not the most common trimetric, but it's kind of an extreme. Now in the real world, all of these axes are all at 90 degrees to each other. There's no way to draw that on a two-dimensional medium. We have to draw at least one of these off at an angle. A trimetric configuration would be, there's something about this drawing it makes sense to have, if I drew this way, something would make sense to show the y direction this way and the x direction just a little bit off of that. And then the z being the vertical. And that's, again, that's a bit extreme, but again, there's infinite ways you can draw it so long as the angle between all three axes is different. Okay. A more common thing that we might see, if I am to draw in anything other than what we're going to talk about isometric here in a bit, if I'm not going to draw an isometric, I will probably draw in a dimetric format. Right? It's page 6. If I draw in a dimetric format, is the angle between two axes pairs are the same. Common example, the most common example I like to draw, this is, again, if I'm not drawing isometric, this is my favorite way to draw. If I'm freehanding, a lot of times I'll draw in this configuration. Again, just like with the trimetric, there are infinite possibilities to do a dimetric. but this is one I like, where I'll put the Z vertical, I'll put the Y perpendicular to that. Okay? So the Z now is all lines that are vertical stay vertical in my paper. Any lines that are left to right are also stay left to right in my paper. Anything that's into or out of the page in the third dimension, right? So anything that's into or out of the page, I'm going to draw off over here at roughly halfway in between those two. Right? Notice what I've done here. I've kind of dotted that line in very lightly because I'm working in pen. I have no way to erase. So if I draw that off wrong initially, I'm going to have to scrap the whole thing. Right? If I'm in pencil, if I do a light dot, I can erase it a lot easier. Once I get it in about where I want it, and that's not perfect, but that's pretty close, right? And so the angle here is, it's 90 degrees as I've drawn it between X and Y, or Z and Y. It's pretty close to 90 degrees, not exact. And roughly the same angle between these two, whatever that is, 135 roughly. That's for me, that's the easiest way to draw in dimetric. But again, just like with trimetric, there's infinite ways I can do that, so long as the angle between two pairs of axes is the same. It's dimetric. I could squeeze this down, right? Make this, 80 degrees, and then make both these 140 or whatever adds up to be 360. As long as the sum of all angles adds up to 360, you're not violating any rules. Okay? That's a common way to do dimetric, especially if you're on grid paper or just freehanding. I highly recommend that. Okay? And then the third one, excuse me, the third one is isometric. That is where iso meaning same, right? Metric being what we're measuring. Isometric is the angle between all axes are the same. Right? And that's basically 120 degrees. Right? So common way to draw that is because it's 360 degrees all the way around, you're dividing it up into thirds. And so I'm not going to get this exactly right, but roughly something like this, where it's the same angle between all three. And if I'm drawing I can freehand isometric to an extent. I'm not quite as good. I'd rather freehand in this dimetric configuration I've shown you here. But I can freehand an isometric, and that just comes with practice. Okay. So if we were to kind of quickly here draw a cube, okay, based on these configurations here. So what I like to do is if I'm going to draw something freehand without a grid, I like to draw what angles am I going to use, like what orientation. So if I draw dimetric, a standard dimetric where I put Z vertical, Y left to right, and I'm drawing X roughly off and down this direction over here. Okay. Now again, these are what we call parallel projections. And what that means is all of our lines are going to be parallel to these. So this isn't my cube. That's not a cube. Let's draw the cube. And a lot of times if people have shown you neat tricks and ways to draw a cube, they've probably shown you some version of dimetric. Okay? So if I wanted to draw a cube in dimetric, what I'm going to do is I'm going to keep all of my lines parallel to these others. All right. So the front, you could draw the front face, if you will, and those are all going to be up, down, left, right, because that's the orientation I've drawn here. When that student comes back, that door may be locked. If somebody knocks on the door, you might let them back in. Now, so the lines that go back basically into the page, so this is what's right in front of me, the lines that go back into the page, we're going to keep parallel to this X line up here, right? Because this is a parallel projection. It means all the lines are parallel to some axes. Okay? unless they're off at an angle, unless I've got a complicated object. But so now I'm going to draw to connect those two. I'm going to draw a line that's parallel to y. Right here. I'm not going to force the lines to intersect. I'm going to just continue extending them out until I find where the two lines intersect. Common mistake is you know, if I'm drawing, if I don't know where this corner is right here, right? And so the common mistake is we draw a line down, you draw this line to meet it. No, don't do that. Dot this line down, and then dot this line up parallel in the x, what we define as the x direction, right? Parallel, roughly parallel to these, and then find where the two intersect. And then go back and darken to the intersection point. Okay. And again, as I've mentioned all along, I'm not expecting you guys to be artists. We just want to be able to communicate. You can see, that's not a great drawing. I'm not 100% proud of it, but it gets the point across, right? If I could sit down and roughly draw this out, you would understand what I'm telling you. And that's our goal, is to get to where at least rectangular normal surfaces we could draw out pretty roughly and pretty quickly. If we try to draw this in an isometric, this is a little more of a challenge to draw an isometric, but it's not too hard. Again, my preference is to draw reference angles just off somewhere over to the side so I can see them, and all of my lines are going to stay parallel to these. Right? It's going to be parallel to one of these three, and we'll call this x being, this is kind of this way, up and down, up to the left and down to the right is x. Down to the left, up to the right is x. Down to the right, up to the left is going to be y, and z is just up and down. All right, so it's a little harder to draw this cube in isometric, but it's not hard. So I'm going to draw the top face first. Top's this way and this way, so I'm going to draw these on the top face of this cube, lines that are roughly parallel to my x and my y. And then I'm going to, from those corners, I'm going to dot those lines out. I don't know where this point here is. So I'm going to just kind of find it by where those two lines would intersect. And that tells me, all right, we'll go back and dot and darken those in. And sometimes that method works pretty well, extending from one starting point of a line, extend it out in the direction that line goes, and then using the other parts of the part, figure out where that line should end. That's a fairly common method you can use. It's not the only one. It's not going to work every time. But a simple object like this, it's not bad. Same thing, you know, I don't know where these corners are down here. So what I can do is from each of these corners, I can dot lines straight down. That will help me figure out where those points are going to intersect. Right? And then, you know, if you've got a ruler, we can roughly measure, well, it's going to be, but the links are not perfect because this is two-dimensional. I'm sorry, this is trying to represent 3 dimensions on a 2-dimensional media. Not all the dimensions are exactly the same. Okay, but we can get the point across pretty easily. So we'll say it's this tall in the vertical direction. So I'm going to dot a line parallel in the y direction to intersect this vertical here. That tells me where those are the endpoints for this line. And then that's going to define the endpoints for this line. I can go vertical here. And the same thing here. I need to draw a line in the x direction, so as close as I can parallel in the x direction, dot a line, find the intersection over there, and darken those. Again, these are examples then of pictorials. Represents 3-dimensional image on a 2-dimensional medium. Requires a sacrifice. In this case, we're going to for sure sacrifice the angles, but we're going to do it in a consistent fashion. Right? A consistent fashion. A common thing we'll do in a lot of multi-view drawings is we'll include an isometric pictorial in the multi-view drawings. So we'll include front, top, and right projections, and then an isometric pictorial. Okay, so let's try to do that. so while I'm gonna exit full screen here. All right, so I'm gonna start up in the background here. We're gonna use SolidWorks. I'm gonna go see, it should be on this computer, hopefully. SolidWorks, there we go. You don't have to start up SolidWorks on yours. I'm just gonna start up on mine. I'm gonna pause recording just for a second. Resume, okay, so we're recording again. All right, so let's go share screen, share. So now we can, all of us can see what we've got here. Okay. So let's look at this guy. Okay, let's look at this guy. Now, here's the thing. This is a two-dimensional representation. This is on a two-dimensional screen. This is a three-dimensional object. Anybody, is this messing with your head of, is that the little square, is that an innie or an outie? Oh, I just changed it for you, didn't I? Yeah, now you see it. Is that an innie or an outie?
I'd say it goes out.
And the true answer is, given this projection, both are correct. If we forced some, you're right, the comment was made about shading. If we force some shadows, our eyes will pick up on the clues and our eyes will tell us, okay, that should be in, that should be out. Because our eyes actually are generating a two-dimensional projection. Each eye generates a two-dimensional projection. Our brain stitches the two together and tries to make a three-dimensional representation. Our brain's really good at figuring out, there's a shadow here, that tells me it's three-dimensional, it's going in or it's going out, whichever the case may be, right? If we're looking at, so if I stop share, we'll go back to the camera here. So if I'm looking at three-dimensional projection of it here, that's, you can see, I mean, your eyes tell you exactly, and it's almost like it's comical to see one that's outie, right? That doesn't make a lot of sense. We literally had to 3D print this, right? There's not a good way to machine this otherwise. So it's, again, our eyes are really good at telling us which one it should be, okay? But with just a two-dimensional image without proper shading, it's really hard to communicate that. And that's the reason we use orthographic projections to tell us which one is correct. So if we look at a multi-view drawing again, right? So again, let's look at a multi-view drawing. And so if we draw this thing, and I'm going to draw it kind of roughly with you here. I'm going to draw the pictorial. But a common thing that we do with the multi-view drawing is we're going to draw the top over here, we're going to draw the front here, and we're going to draw the right here. And then we'll put a pictorial up here in the corner. Okay, that's the common way we're going to do this. Now, if we look at this, it's like, all right, well, what is the front? What is the right? What is the top? It's up to you. I'm going to say if this is the front. Okay, so if I'm looking at three-dimensional, the front is looking this way. I'm going to orient it this way, this being the front, this guy. And that's how we'll look at it. Okay, so if we do that, I'm going to draw the pictorial. I'm going to draw it isometric up here in, I'm going to draw my drawings down here, but I'm going to draw the pictorial up here. Right, and if we look at this guy, well, I'm going to draw this top face, and I'm going to draw this face down here. So I'm going to do that. So I'm going to go kind of quickly. Interest of time, I'm going to dot the long lines out. Right. Now again, we're drawing it like this, basically, roughly like this. This is the orientation we're going to try to draw it in. So I'm drawing these lines here first. So I'm going to draw these lines. And again, as we said earlier, it's a good idea to draw your reference angles over here. This is X, Y, and Z. So I'm going to draw these lines on it, dot them in roughly, and then go back and make them good, solid, visible, thick lines, because they're visible in this view. I'm going to draw this line here and this line here. I'm going to kind of guess at the length. I know they're shorter than these, So I'm going to draw this line in the Y direction, as close as I can, parallel to the Y direction, but not as long as this one up here. About 2/3 of the way. Okay. Same thing here. I'm going to draw one about 2/3 of the way, 2/3 of the length of this line over here, parallel to it. And then I need to find this intersection point, because I'm going to draw this whole face. I'm going to draw this intersection point right here. So I'm going to dot in from the end of this line. I'm going to dot up in the X direction. From the end of this line, I'm going to dot up in the Y direction. Try to be careful with your dots if you're drawing in pen. If you're drawing in pencil, or if I'm drawing on the whiteboard, it's easy to erase. It's okay if I draw too much, but if I'm drawing in pen, I'm not going to have the erase option. So unless you've got an erasable pen, just be mindful of that. Okay, and then I'm going to draw this face down here. Okay, so I'm going to draw this face in. So I'm going to draw lines down in the vertical direction from this corner. Well, actually, this face is a little harder to draw. So I think what I'm going to do is I'm going to try to find this point down here, the bottom point. Okay, so if I can find that bottom point, so that means I'm going to dot a line down, straight down here. And by the way, there's 500 ways you could draw this object. You don't have to go in the exact order I am. I'm just telling you how I see it, how I'm approaching it. Any way you can achieve this shape in an isometric configuration, go for it. I'm just telling you what I do. Right? So I'm going to dot this line down. And I'm going to say probably from right about here. I'm going to dot in the Y direction out a little ways. And from this point here, I'm going to dot out. And that's off a little bit. Dot out in the X direction. And try to find their intersection. And once I've found those intersections, I'm going to go back and darken those all in. And that kind of gives me the overall outline for the shape. Not doing a great job of it, as you guys can see, but okay. All right. Now, I need to try to get up here to this little innie, if you will. Well, I'm going to dot up to a point here. Kind of guessing at the length of this line here, but I know it's going to be shorter than these other two. And then I just need to basically kind of flesh out the other lines that are in this smaller cube inside. So I'm just going to kind of start fleshing those out. I know I'm going to have a down line, and I'm going to have a line here in the Y direction. I have a line in the X direction, and a down line from here. And again, I'm kind of forcing my intersections, which is a bad idea. But I'm also trying to go reasonably quickly because this entire lecture is going a little longer than I really like it to. And then from this corner, basically I'm going to find the point in here. And this point, I need to find it. So I'm going to dot in from these corners in all the directions. Establish what those lines should look like and draw those in. So again, not great. I've drawn this thing a bunch of times over the years, and you can see that's still not the best drawing. Right? It's harder when I'm trying to explain as I go, but you guys get the idea. Again, that's the pictorial really doesn't solidify anything for us. It's helpful. What we really want is the projections, the orthographic projections. That's really what we're after here. So what I'm going to do is I'm going to draw a top, front, and right around this. I'm going to be very careful to line these up so they work together. The easiest way to get this wrong is don't line these up. Right? Just draw them all over here, front, top, and right. Just draw them, done. None, never. I will count that wrong. Not a lot of points, but I will count it wrong. Your projections should always line up because they work together. The projections should work. No one projection fully defines the part. They should all work together. So make sure they line up. And so I'll show you what I mean there. To do that, I'm going to draw the front projection, right? Again, this is looking up in the X directions, the front projection. So in the front projection, I'm going to see this L-shaped face, and I'm going to see this little face. And how do I mean, it's pretty easy when I've got the object in front of me, right? What I'm saying is I'm looking at this as my front projection. So that's what I'm going to see. That's my front projection. So like I said, it's really easy when I've got the object in front of me, but that's what we want for the front projections. What do I see if I get eye level and I look right at this thing? Well, front projection, I'm going to see an outline of a square. And again, these are all visible lines, so I'm going to go back and darken them just a little bit, make sure they're good, solid, thick lines. All right, and then again, the front projection, I see this face, and I should also see this face up in the top right corner right here. So I want to draw this face also. You can see this one. This is my front. Now, as I was saying earlier, really important, these need to line up. Your top projection, you can extend dotted lines up here if you like. Your top projection will have the same width as your front. Right? Because if this is the front, this is the top. This width is this width. They should line up. They should work together. So I've extended dotted lines up here because my top projection, which I just set it on my top right there, right? This is the whole thing. That's the top. So that's how we're going to draw it. The top has the same width as the front. Okay, but you can see I've got this little square right there. Okay. And I've done a terrible job, but these should be the same width also. So this actually should move over just a bit. Okay. These should be, all widths on the front should be the same as the widths on the top. If you'll line those up, that helps get that right. Now notice that if I don't have these, if all I have is this, again, is this an in or an out? Don't know. So that's black. And if I'm just talking in 2 dimensions, I don't know if that helps. A little bit. Something, right? So you can see, you'll get, it's what we call ambiguous. They're both correct. This front projection is correct for both of those. But when I look at, okay. Okay. But you can see when I look at the top projection, you can tell which is which. Right? You can see the obvious difference in the top projections of the two. So that's the reason in the top projection, this one alone tells us, well, I'm looking at this, not this. I can't tell that from the front. I need another view to tell me that for sure. Okay. All right. Let's draw the right. So the right we'll draw over here. The right is going to have the same height as the top, as the front view. Right? The same height as the front view. So I'm going to draw the right over here. And again, the right is looking up in this direction. So the right view is going to look like this. See from this direction. And then if I extend this out, I can see how deep this should be. I will see in the top kind of left-hand corner of the right view a little square there. Again, if it were this, this would protrude out. It's not. It's this. So it have this cavity there. The 3 projections work together to define the whole object. Questions here so far?
Is it useful to think of it like Huber? That's how I'm thinking of it.
If that works for you, absolutely. Does it work to think of it like Hubert, the game? Hubert, yes, absolutely. Whatever works for you, because That is an old school three-dimensional game that they very much only had two-dimensional graphics to try to represent. And they did an amazing job. Yes, that helps. Go for it. Yeah, I know, right? Yeah. This is your right projection. Other questions here. Common thing people will do, and I suggest this, if you'll label your faces, sometimes that helps. We could say this is A, B, this is C, D, this is E, F, or whatever you want to call them, right? And I could say, well, this is, all right, this is A, B, this is C, D, and this is E, F. Feel free to label your faces. I don't require it. So well, there is one assignment where I ask you to match the letters to the numbers, right? They give you this basically, and they ask you to correctly identify in the different images which ones are which. So it's a good skill to have. It's not always required, but it's definitely something to think about. Other questions here so far? All right, let's talk just briefly about, I also ask you in the assignment to take something like this and draw it in 3 dimensions. It's not hard, it's not simple, but it's not hard to go from the 3-dimensional object to the 2-dimensional images. And I'm glad, I feel like this actually worked out pretty well, me just putting this on there and projecting it, and you seeing it literally in 2 dimensions. I feel like that, I don't know about you guys, but just looking at kind of how this went and judging by your reactions, I feel like that goes better than this normally goes. So hopefully that's actually helpful. But it's a little more of a challenge going from a set of 2-dimensional drawings to the 3-dimensional drawing. Okay? So we go share screen. I've got a PDF here of, this one's a little more complicated, but this is a multi-view drawing of an object. And we're going to draw this in 3 dimensions. Okay. All right, so roughly, and I'm going to draw this, I'll draw this with you, but kind of see it here. So let's see, I don't think can I? For those of you here in class, I think we'll do this so you can see me. I'm going to draw this with you, because I know some of you guys are drawing this in your notes already. So I know this is a little small for you to see, and the people watching this on YouTube, you don't even see it at all. But if I draw the top projection here, actually I think the people on YouTube will see this video, the little thumbnail here. If I draw the top projection here, right? So this is the top projection, right? The outline of it appears to be a square. It's roughly, the scale here would be 9 by 9, 9 wide by 9 tall. So this is roughly a 9 by 9 square. Now I think I can get a little more real estate there. We're probably really exceeding the capabilities of this computer, and that's okay. Yeah, that's probably all I got. All right, so roughly a 9 by 9 square. So if you're using 1/4 inch scale, what's that, 2 1/4 by 2 1/4, whatever. And again, these don't have to be exact. I'm just giving you rough dimensions here, okay? These little squares here, these are basically 4 tall, and they're about 2 wide. And there's one over here. These are essentially symmetric. About 2 wide and about 4 tall. Whatever units you want to use there is fine. 4 tall, 2 wide. This is 2, and so it's a 5 gap in between. And there's a 1 gap, very thin gap in between. And so that's my top projection. 9 by 9 square with some different features there. I'm going to close SolidWorks. Hopefully that frees up some resources. Okay, so we're really pushing the tax in the computer today. All right, so this is my top. If I draw the front, The front is a 9 by 7, so it has the same width. I guess it's a 9 by 5. Yeah, it's 9 by 5. So it's 9 wide. It's only about 5 tall. It's not as tall as it is wide. It's a rectangle. It has the same width as the top. 9 wide. And you've got this little other feature on this front face. We'll say that it's 2 deep. And again, it's 5 wide. Because all the widths on the top match the widths on the front. So 2, 5, 2, and then 2 deep there on that front view. And then all of the heights will match up on the right face. So it's 5 tall, and it's 9 wide. So it goes 4, and there's this little dip. It's about 1 wide, 2 deep, 1 wide, and another 4, 9 across the bottom, close it off on the right. Now, what I like to do is I like to show you how do we draw this on an isometric grid. So let's see, I need to stop share. That takes me back here. So I'm going to draw this on an isometric grid. So I printed some isometric grid paper for you. All right? And you have this available in your Canvas. You can Google isometric grid images and paste that into a Word document and then print a bunch of it. That's what I've done here, right? So that's available to you in your Canvas. You can print these out. The textbooks that we used to use, they would have these grids in them that you could just pull out of the book. But you can print these easy enough. If you want to use these, you don't have to use these, right? So here's what we're going to do. This, again, this is the top, this is the front, and this is the right. So a common thing, there's a variety of ways you can do this to take 2-dimensional images and draw it in 3 dimensions. A variety of ways you can do that. A common strategy a lot of texts will employ or tell you to use is make the biggest, largest outline shape and then start cutting away the parts that you don't need. So think about it if I was to make it in like a wooden block, right? So if I wanted to make this guy, well, I would draw the whole big block roughly and then draw this section cut out of it, okay? Now, what that means is you either draw with a pencil and you erase stuff, or if you're drawing with pen like I'm going to do here, you just have to be very light in your initial drawing and then very dark in your final drawing, okay? Either way works. So if I'm to draw this top projection on this isometric grid paper, so it's going to be kind of laid in here about like this, okay? Something like this. Come on, image. Our projector here is not wanting to work with us. There we go. So what I'm going to do is I'm going to start out with a 9 by 9 grid across the top. I'm going to kind of pick a point in the middle at the top here, and I'm going to dot down. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to dot. I'm not going to darken that yet because not all of it's solid. But that's going to represent this edge here. And then this edge back over here, this one is solid. So I can go ahead and make it solid. Well, actually not yet. I'm going to just say this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, it's easier if you do this in pencil so you can erase it as you go, because we're not going to need all this. I'm just roughly kind of putting in where this roughly lives. All right, so I'm going to kind of dot across here. Let's see. Probably right about here. So I'm going to roughly kind of dot across this way. and roughly kind of dot across this way. And you can actually count the grids. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. That's the reason for the grid, is you can actually count the gridded space. Let me double check that number. 1, 2, 3, 4, 5, 1, 3, 4, 5, 6, 7, 8. Actually should be right here. That's the reason why I double check that. So is this one 9? It's 1, 2, 3, 4, 5, 6, 7, 8. Sure enough, it actually goes out there. Okay. So it's actually to there. So this is roughly the outline for this top face. This front face is a 9 by 5, so I'm going to draw that right in here. Okay. Because again, this is the front and back is this way, the left and right is this way, and then top and bottom is vertical when you're working isometric. So the front face is going to be roughly here. So it's going to be 5 tall. It's 1, 2, 3, 4, 5. And from this corner, 1, 2, 3, 4, 5. And then those appear to line up. So roughly my front face is here. And the same thing over here. My right face is going to be 5 tall, 9 wide. So I just need to establish that as 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, I know it's hard to see, and I'm trying to keep this just as light as I can, because I can always darken it. Once I've got it down, because I'm using pen here, I can't erase it. If you use pencil, you can erase it. Right? But it's a little harder to see on a projector or pencil drawing on this background. Okay, so that's roughly the outline of where this guy's going to live. Now we just need to start going in and putting features in. There's a variety of ways you can go about this. One thing I like to do is I like to say, all right, is can I tell of all these faces that I see, all these different rectangles I'm seeing here, can I tell which one is like the furthest out, right? Which one is closest to the viewer? Well, when I've only got one face on a projection, that's the one that's closest to me. Does that make sense? Right? There's only one here, so this one's got to be the one that's closest to me. Which of these is closest to me? Well, I'm not sure yet. Can make some guesses. But this one, there's only one face here. This is the one that's closest to me, right? And this, when you look at these other projections, it's not like there's half of it gone, right? It's basically, where is this face on these projections? Where is this? Well, stuff on the right is going to be over here. So where is this face? Well, it's right there. It's right up, because it's the only face. It's going to be the closest to me, and that means it's probably right here, all the way at the farthest right of this image. And we said that this is 4, 1, 4, and it's 5 tall, and it's 2 deep. This gap there is 2 deep. So it's going to be 1, 2, 3, 4. And again, I'm telling you how I see this. If you see it a different way, that's fine. We can get to the same place a variety of ways. And practice is going to make perfect here. It's going to feel a little awkward. I'm going to ask you to do a couple of these, and that's really just kind of the basic. Like you want to do a handful of these. I've given you a bunch to choose from and asked you to do 2 of them. If you want to do all of them, do it. I'm only going to grade 2. I'm only going to give you credit for 2. But practice will make perfect. The more of these you do, the better you will get at them. Okay. But again, I'm walking you through how I see how to do this one. I see this right face as being right at me because there's only one face on the right. That means it's probably right here at me. So this line, this vertical line here is solid. This line here on the bottom is completely solid, 9 long, solid on the bottom, on the right projection. So that is this line right here is a solid 9 long line. this other edge over here. That's the vertical, so I'm going to have 5 vertical solid right here. And then the only hard ones across the top here, I've got 4, 1, and I've got a 4, 1, 4. I've got a gap in between there. It's 2D. So I've got one line here for 4, another line over here, 1, 2, 3, excuse me, 4. And I've got this gap here. It's going to go down, 1, 2, go over 1, go back up, 1, 2. So again, if you want to label your faces, if we call this face A, this is face A. That's my right face. That's what this is what I'm seeing right here. Now, the other faces are a little more challenging, right? So this front, this is what I see if I'm looking up this way. If I'm looking up this way, this is what I see. If I'm looking down, so that's this projection. If I'm looking down, this is what I need to see. And we start trying to piece those together. And I say, all right, well, which can I tell? Again, the thing I like to ask is, can I tell if any of these faces are closest to me? Okay. Well, this right here looks like, you know, and there's always kind of this lineup like this, right? Things should, if I kind of draw an arc between the front and the right, there should be some lineup there, okay? Have fun with physics. All right, so we should be able to, this block right here, if we call this B, B looks like it's going to be right here. And sometimes you have to draw one of these and it just doesn't make sense and you scrap it and you draw another one. And that's okay. Again, another way to think about it is think about if I was to cut this out of a block of wood or a block of cardboard, how would I do it? Well, I need this up at the top. This becomes face B. Yeah. Okay. And what do we do with these other guys? Well, and again, this one is a bit of a challenge. And I do this one because it is a bit of a challenge. It forces us to kind of think about it. If all we do are the simple ones, then we're not challenged enough, and it's tough to do anything challenging after that, okay? All right, so then we kind of pick. It's like, all right, well, which of these should I go with next? Well, if you look, these kind of correspond. These correspond. It's like, where would this U shape be? Well, it's probably right here, right up at the very front. So if I say that this is face C, and I think face C is right here, this U shape right here at the front, let's try to draw that. So this is too wide here. This one is too wide here, and I'm going to draw basically this U-shaped C face right here. Well, it's 5 tall on both sides. I've already got this line over here. This bottom line is solid, 9 long solid. And then it's too deep for this gap right here. This, you can kind of finish out the U shape. So it's too tall right there and too tall right there. And this baseline right here is 5 long. So this becomes face C. And then we can start to say, all right, well, where are these other things? Well, if I call this D and E, you can probably maybe start seeing where those are. Those are, if this is face C right here, they're kind of up on top of face C. They're these guys right here. And we said these are 4 and 2. So these are 4 by 2s. This is right here. It's 4 and 2. And 2, so it's 1, 2, 3, 4. 1, 2, 3, 4, and 2. So if I'm sticking with my labeling here, this is D, and this is E. Okay. Now, what do we do after that? Well, honestly, after that, this one actually gets really, really tough, and that's okay. We just try to look at and say, you know, and this is more challenging than what I would ask you to do on a test. Something that you just had to sit and kind of play with over time. Have your pencil and your eraser ready. It looks like this should be a solid line right there. Let's finish this column, the column that D rests on right here. So from this corner right here, I'm going to dot in 4. So it's 1, 2, 3, 4. And it's too tall there. So something I can't see, this would be a hidden line. Right here would be a hidden line. Right? That's this would be a hidden line right here, would be this one. There's one here behind that we can't see. That would also be hidden, but we don't necessarily have to add that here. What else do we need to add? Well, there's right here. You can see right there, that's visible. Then it's hidden through here. And then it shows up right there, becomes visible again. There's a line right there. And I think that's probably all the visible lines we could see here. We could start adding the hidden lines in here, and it will start getting very busy very quickly. Right? If you don't have to add the hidden lines to communicate what you need, especially on a pictorial, don't. Add the hidden lines as you need them on your projections, right? But if I don't need hidden lines here, that's kind of what we're looking at. Again, this one's a bit of a challenge, and that's okay, right? It's okay to talk about how do we work through a challenge one. You do have an assignment in Canvas. I'm going to stop recording here and then mention the assignment here because that may change from semester to semester. Right, thank you those of us on YouTube for joining us. Stop recording.